Welcome back, everybody, with circuits. Today we're going to be talking about Kirchhoff's current and voltage law. Okay, it's all stuff we've kind of learned about, but we're just going to be doing a little bit more practice and putting a name to it. So current entering a junction will equal the amount of current leaving the junction. Okay, so junctions are whenever the current is able to split off into different paths. Okay, so that's why a junction is there. Let me explain this a little bit. Okay, so there's 6 amps of current that are going through. Okay, move in here. And then 6 amps. And then some of it's going to split off and go this way. And some of it's going to go this way. We can see 4 amps goes this way and 2 amps goes this way. And then there's 4 amps here. It goes through this resistor. There's still 4. And then it goes through this resistor. There's still 2. And then they come back together. And then there's 6 again. Okay? So we've kind of learned about this, but whenever they go into a junction, they'll split off. And then when they come back again, they'll equal the same amount. Okay? When we look over here, we have 12 going through the wire, enters this junction, 2 goes this way, 10 goes this way. 10 is continuing to go this way, and then there's another junction. Oops. 6 goes down, 4 goes to the right. Okay? And then we go back to this junction, 6 is going back into it, and 4 is going back into it, and then we have 10 going out of it. And then for this one, we have 2 going into this junction, and we have 10 going into this junction, and we get 12 again. Okay, it's all things we've learned about, but we're going to be doing a little bit more practice with it. Okay, so what is the current in positions A and B? Okay, so we have A here and B here. Okay, so we have 10 amps of current going through, reaches this junction, 7 goes this way, and that means 3 goes this way. Okay, so that means all of this will be 3. So A will have 3, and then 3 will go back into here, and then 7 will go back into here, so then this will again be 10. So over here will also be 10. So A will be 3, and B will be 10 amps. All right, moving on. What is the current in positions A and B? Okay, so the current's going through here. There's 20 amps. There continues to be 20 amps over here with position A. And then things start to split. 12 goes this way. 4 goes this way, which is a total of 16. So that means another 4 has to go this way. So B will have 4 going through it. Okay, so we have 20 and 4. 20 amps and 4 amps. All right, moving on. So now we're talking about Kirchhoff's voltage law. We've also learned about this, but the total voltage drop within a closed loop equals the total voltage. So if this is 20 volts, that means all the voltage drops need to add up to 20 volts. So in this case, we have 2 plus 4, which is 6, 6 plus 6, which is 12, and 12 plus 8, which is 20. Okay, so they all add up to be 20. All right, moving on. So what is the voltage change through R3? Okay, so we know the total voltage change is 40. We have 15 here, 5 here, and 2 here, but we don't know what this one is. So let's just add all of this up. 15 plus 5 is 20, and then we have 22. So it needs to add up to 40, so this has to be 18. Okay, so it'll be 18 volts. Moving on. What is the voltage change through R4? Okay, so the total is 120. We have 40, 25, and 35. Add them all together. 65, 100. So this should be 20 volts. Okay. And that's pretty much it. It could get a little bit more complicated when you add parallel volts into it, but we're just going to kind of stick it to some things that are a bit more simple. Thanks for watching, everybody. I'll see you with the last one where we start talking about things that are in parallel and in series, which is probably the most difficult. Bye. See you for that.